Okay, these notes are about the electromagnetic spectrum. So here's some components of a wave. The wavelength is from crest to crest. The frequency is this wave has a low frequency, but a very long wavelength. This wave has very high frequency, short wavelength. So they have an indirect relationship. Your wavelength increases, then your frequency decreases. So light is a continuous spectrum. This part right here is the only light that we can see, but there's other types of waves. So here's your formula. Speed of light is c. C will always be this. It's a constant. Then your wavelength, which needs to be in meters because of your speed of light constant. Usually wavelength is given to you in nanometers, so you'll have to convert. There are 1 billion nanometers in 1 meter. And then your frequency. And I usually write frequency as F instead of V, or whatever. All right, so we want to find the frequency of a green light that has a wavelength of 545 nanometers. All right, so our equation, C equals wavelength times frequency. C is always 3 times 10 to the 8th. Your wavelength, they gave you nanometers. I converted to meters. Divide both sides. You should get 5.48 times 10 to the 14th hertz as your frequency. So Max Planck hypothesized that the energy radiated from a heated object, like a stove or a light bulb, was emitted in discrete units. So you would think that energy is a continuous stream, but really it goes up by a step, a full quantum, a packet of energy, or not at all. So each staircase would be 1 quantum of energy for any frequency of electromagnetic radiation. So this was Planck's formula. This was his constant. You don't need to know how he figured that out. So his energy was per quantum or step, and his frequency. Then Einstein came along and he did his whole theory about how energy, light can be a wave or a particle. So now, instead of a quantum, it's a photon, and then we get that term from Einstein. Okay, so we want to find the energy of a photon that has a frequency of 4.5 times 10 to the 14th hertz. So that's your equation. Planck's constant times your frequency. When you multiply them together, you get that, and energy is in joules. It's your unit. All right, try these homework problems, and we'll check it in class.